3 today, and a bit of Spring 5 because it's a kind of a big story for Spring 5. My name is Stéphane Maldini, and I work for Pivotal, and I work from London currently, but I'm French, obviously, for my accent, so you can guess that. If you don't understand whatever I say, just interrupt me, and I'm going to, try to repeat in a slow motion. So let's go. So I'm going to talk about reactive, and reactive has been coined. The term reactive has been coined a lot, unfortunately, with a kind of hype train and hype machine, and it's actually quite normal stuff, and it's not even new, and it's really correlated to distributed systems, because reactive, the notion of reactive, even if it has been presented in a few manifesto around, the notion of reactive is really something that is around for 30 or 40 years now. It comes down to, most of it comes down to, or a lot of perception of it comes down to event-driven programming. But what I wanted to say in this magnificent slide is simply that the reactive I'm going to talk about now, the reactive notion I'm going to talk about now, is not necessarily the reactive you understood before, maybe in the past, or the manifesto you understood in the past. The reactive notion I'm going to talk about is a reactive notion which is bound to a specification agreed by different company with real definition of what it is. It's not like a functional concept, or some people saying, okay, I'm going to do something asynchronous, I'm reactive. It's really based on something solid, so it's different, and that should change the perspective a bit. And also that's why Spring, with the maturity of the specification around reactive, that's why Spring also started its new story about reactive. So what's the story? Nowadays, most of the architectures we try to discuss with customers, because we'd love to sell them the idea of microservices, is really the idea of distributed systems. Something is reacting to requests from connections from mobile client, for instance, or desktop clients. And this thing, which we call a microservice, is going to maybe aggregate, I coined the term earlier, actually, with Andreas, maybe aggregate the microservices behind for doing, I don't know, payroll processing, or maybe aggregating data from a data store behind, or even maybe collecting messages from a message broker. So really, it's each application in that kind of architecture becomes a kind of micro proxy or forwarder to enrich the data coming from upstream and respond to downstream with some data, meaningful data for the clients, like the HTTP request coming from your mobile clients or desktop clients. The problem in that picture is, of course, the small numbers we see in this in the various rows between the different components, and that is latency. Latency just means that the data doesn't teleport from a remote host to a local host. Latency just means it's reality. It's a physical law. Data is an electric signal transmitted from a server to a client, in that case a microservice A, and this is not going to be immediate, because there is some distance between the servers, physical distance, and it might even be affected by the state of the traffic, if your network is congestion, this kind of thing. So it's a random number basically, and predicting it is hard. You can benchmark, etc. And actually, a lot of papers talk about how do you trace this kind of metrics. And one of these is one of the results of these studies is actually something we work on as well, which is called Zipkin, to really measure between microservices the exact cost of the latency. And that's a different project which we also support in Spring. So once you get these numbers, what we do to deal with these numbers, basically, we have to be in the application, in the microservice, kind of defensive about how we're going to address the fact that the data doesn't teleport locally from a remote service. And the data, in fact, inside the application might be transmitted between even two different resources, because often we forget that we can also work in a distributed fashion, but inside an application. Communicating between threads is not also immediate. You have to go through the L2 or the L1 cache through the CPU and switch boundaries between the two threads, basically. So this kind of internal communication is often useful, because when you have a data which might take time to come from an upstream component, you will usually use an asynchronous boundary to make sure that this long call is going to be isolated in a kind of executor service task or something like that. But that comes also with issues, which we're going to see just after that. So the deal is, if you have to communicate back pressure, latency, I'm going a bit fast, latency between components from upstream to downstream, there needs to be something, if something upstream is a data store, you're going to access the data store with a component, and you're going to forward this data to an HTTP response, for instance. And there needs to be something to inform between these two components that's going to be slow, and then maybe I don't want to, I want to do something if it's going to be slow. I want to have a kind of preventive action, because there might be some issue if you just let the flow going on in a push fashion, data coming without limit to your microservice, and then transmitted without limit to your clients. So what kind of issues we can come over? Well, if you take a data source as an example, I'm directly using the example as a push example from not necessarily a query you will do, and that will be kind of pulling the data from a data store. But imagine that you have a data source pushing data items over time to an HTTP response, maybe a SSC server-side event response or WebSocket response or whatever. It can even be a normal HTTP response. You can stream on a normal response. If you start pushing data, and it's a blocking response, you might have what we observe as a kind of issue if you have slow client, because if you have a slow client like a mobile client, you will be forced to wait for the client to actually receive the data. That's the way TCP protocol works. It will have a window, a timeout window, etc. But still, it will have acknowledgement mechanism, and this is driven by the same concept of latency. You have to wait for the traffic to come by to the client and come back to the server. And if you have this kind of mechanism, which is quite current or standard in the JVM or any other technology, if you have a blocking response and try to push faster than the data is actually the client is actually able to read, you're going to have this thing in the middle, which is a buffer or a queue, depending on the vocabulary you use, which is going to be filled. And if you take the case of an executor service, for instance, if you, for instance, use an executor service to isolate this call, this response right back to the response, itself as a queue as well. So what's the limit to the queue? Well, it depends on the queue you want to pass as a factory, maybe to the executor service, but most of the time you don't even pass any configuration to the queue, or a limit configuration or a rejection configuration to the queue of the executor service. So it's quite aggressive. In one case, by default, the executor service will accumulate data without any limit. So if there isn't any limit, if it's an unbounded buffer, well, the JVM is going to set a limit, or the machine is going to set a limit for you. You're going to reach the out-of-memory exception at some point, because that's the way we actually limit the JVM application from consuming all and taking too much time to do the GC as well. So you cannot use unbounded. It's not permanent or a stable solution to use unbounded queues. If you start using fixed queues, then you have another issue. And in that case, let's say we have a blocking queue, for instance. What happens to the next item, which is going to be buffered on a completely filled buffer? Well, nothing will happen. It will block, and we will prevent returning, which is going to hold the resource, maybe the HTTP thread you're running on, or maybe the database server thread, for instance. And if you take all of this resource, then it's one resource left to consume your data. You can say, and I had this discussion just before the presentation, you can say in a Tomcat container environment, for instance, you might have 1,000 threads maybe. And if you block one because the client is slow, it's fine. There are 999 other threads to pick up the demand. That's the way the container will work anyway, if you take all of one thread resources. Well, in that case, that's partially true, but if you actually concretely visualize the request context, for instance, it's a slow endpoint, a slow REST endpoint, which is accessing the database, and everyone is going to access the same endpoint, so the logic is not going to change. The only thing that might change is in between. One is going to be slower because it's accessed from a 3G phone network, and the other maybe is going to be accessed by a cable network. So one response might be faster, but if you have a lot of mobile clients, is that going to be a permanent solution? Maybe not, because you're going to just hold all the resources, which is not good. And in fact, in the cloud environment we're living in, having 1,000 threads is not a good solution neither for sharing the resources, because you, in the microservice world, you will have a different microservice for the functional use case. They cannot take too much of the resources because you're going to share, mutualize the resources of the same container or different container. And in that case, maybe it's not a good idea to have 1,000 threads. So the two problems with the blocking code will be to have a kind of poison pill contaminating all of your container, and then your Tomcat server may become unresponsive. And the classic solution to scale it, to overcome that, is to scale out. So you have a load balancer in front. A Tomcat is overloaded or down, so it's going to use another Tomcat, or worse, it has a function of elastic scaling, and it's going to pop up a new VM, which is going to pick up the demand because one is completely overloaded. But these things are not immediate. They are patches to a problem you can solve a different way just by designing a different way, which is the reactive way. It doesn't apply to everything also. Some cases will be better off in blocking. Blocking is always going to be faster than reactive programming because it's the simplest immediate path between logic, a data source, and yourself. If you consume a socket, for instance, or an input stream, and you just read it, it's always going to be faster than using, for instance, Nelly to read this stuff as well. The only difference between the approaches is because Nelly is event-driven, it's going to allow for more concurrent connections. And that's the only thing. The trade-off is you pay more overhead by using reactive techniques to maybe be smarter about the way you schedule the responses. In the case of a REST template, a REST endpoint, for instance, you will be happy if you have a 10,000 3G connection or 2G connection. It will work fine with Netty, but the Tomcat could be brought down by this kind of massive concurrency with slow consumer. So the non-blocking response will be to make sure that the queue is never overflown. So in that case, if we have one item in the queue and we don't want to block the queue at any time, we will only request 3 more items, because it's, if you know that the queue is filled, in that case 25%, you're not going to ask for everything. You're just going to ask for the missing data, the missing space you still have. Otherwise, you will be blocking, but that requires the data source to be smart about this kind of protocol. And that's exactly what is reactive streams, which is defined in reactivestreams.org, and has been adopted in Java 9 under the flow.publisher package. It's a kind of interface with a lot of sub-interfaces. And we define the slot of interfaces is not, in fact, a lot. We defined 4 interfaces in reactive streams. When we created it with TypeSafe, Netflix, Oracle, and Red Hat, we wanted to keep actually the contract simple. It doesn't define operation you will see in Reactor, for instance, like map, flat map, or in RxJava or in AkaStream. It doesn't define any of these things. It just defines the protocol between each of these library or even operation, because sometimes in the case of Reactor, each operation will implement this contract of asking more if you can receive. And This contract defines a way to send data 0 to n. So publisher is an interface with a subscribe method, only one method, subscribe. And once you subscribe a subscriber, the subscriber has actually 4 callback method on subscribe, which is the first one used. Then you have on next, which can be called 0 or n time, but maybe I say 0 because sometimes you would never have data. It's just about the 2 last other signal, which are error or complete. And that's the 4 callback you can interact with in a reactive stream spec. And the important part is, of course, the reverse flow, because once you subscribe a subscriber, this onSubscribe method, the starting callback method, receives what we call a subscription, which is a kind of one-one relationship type you use with there are 2 methods on it, request and cancel. So if you're not interested anymore in the data, you can cancel this subscription. But there is also the most important one, which is request. And with request, you basically say to the publisher, send me that, but no more, exactly no more. And all the implementation of this specification will respect this demand behavior. And we call this behavior as well back pressure. That's why I fast-tracked a bit earlier. And what is Reactor then in all of that? It's exactly mostly the left part. It's implementing for you a way to produce data in a back pressure ready way. And Reactor just provides this set of operations largely inspired from Rx Java to generate or transform data, implement data sources implementing publishers publisher in that case. And why we do that? Why don't you use directly the interfaces from the reactive stream specification? Let's take a quick example. If you had a repository, for instance, and you wanted to use a data repository in Springtime, you wanted to use reactive streams, you will, instead of returning for a find user method that might return one user if he finds a user or nothing, so find user, return user. In the reactive streams world, you will return a publisher of user. So this publisher of user is the indirection you need to avoid blocking the call to find user. If you, in an imperative world, if you call find user, if it fails, it might throw an exception. If it's slow, it has to get the data. So if it's slow, you impacting the calling thread. Find user needs to return a user immediately when you call find user. But in that case, the interesting thing is it will produce a user when it's ready, and it doesn't block the main code. So it's a callback, classic callback-based design. The problem with the specification first, if you just use the specification plainly, you might have an issue with the semantic, the cardinality. So I said a publisher can send 0 to n user, for instance, in that case, because there is nothing that defines how many data can flow into a publisher. So in that case, it's not very interesting for us. We don't know there won't be more than one user. And the other thing is, besides the fact you have to implement a publisher, you have also to implement a subscriber. But the reactive stream specification makes sure that all the burden of implementing the spec is actually placed on the publisher side, not the subscriber. The subscriber is quite easy compared to implement compared to the subscriber, and compared to the publisher. And the subscriber, as I said, has this callback. But let's keep the red line in mind for the publisher user, because you will see it's not that practical to have something like that in real life. Would you, for instance, use in a repository iterable of user to return find one user? No, in general, no. You will just return a user. You don't need to extend or use iterable or list for every call, like get count. You don't return long. You don't return list of long. You will return long, and that's kind of interesting also for programming experience to have this semantic of one versus maybe more than one. The other problem with the publisher specification is once you start using it, you realize there is nothing else you can do than subscribe, because the interface, and it's explicitly done this way because it's complicated enough to model this behavior. It only implements subscribe methods. it only exposes the subscribe method. It doesn't expose any of the transformative operation like map, flat map, filter, etc. It's only subscribe. And we have a TCK to a technology kit to test the various implementation. We pass ourselves, but Stream, for instance, which implements the specification, passes it. RxJava 2 type flowable, not observable, but flowable, implements reactive streams as well, and they pass the same specification as well. So we guarantee that we pass the on-next signal the same way across different frameworks. So can I have an API from that? Yeah, so that's one point. The other point is it's complicated to implement reactive streams. That's a non-exhaustive list of things you have to implement when you are working on creating your own publisher. So first, it has to work with the TCK, otherwise it might not work with other libraries. Then you have to address things like reentrance. It's interesting because, you know, if we have a mechanism to request more data, that means on star, we will request maybe 32 items using the request from subscription. But after 32 items, you might want 32 more items. So you will count on your own next callback. Okay, it's 1, 2, 3, and at 32, or maybe before, if you want to do prefetching, you will start doing your next request. And if it's a synchronous flow, because it doesn't also explicitly say it has to be a synchronous or asynchronous flow, but if it's a synchronous flow, the request cycle is going to be creating a kind of stack overflow, maybe exception at some point. And that's quite hard to address it in itself. Also, the thread safety, because there are many threads that can traverse operation, one in one direction, one in another direction, and some operator, in fact, do more, the merge. You can merge multiple publisher with a reactor, for instance, and that is also complicated per se, etc., etc. So, if you really want to pass the step of doing that all yourself, it's very hard. I think that's the 4th or 5th time I tried myself to implement a reactive library, and David Carnock, the lead of RxJava, is probably around his 7th or 8th time. So we had a lot of iteration every time, trying. We had even before that, we have, if it's 3.0, that means we had version before, and we failed, like all the libraries as well, I suppose, to grasp exactly what makes reactive streams correct or side effect free. That's the most difficult thing. So Reactor is not new in itself. It's 3 years old now, maybe 4. It started in 3 years ago, specifically as a kind of alternative to akka dispatching using Reactor, what we call Reactor ring buffers dispatcher. And they used a pattern from maybe a company you know called LMAX. These guys have created something called LMAX disruptor ring buffer, and that was basically the foundation of Reactor. What we wanted to do was an alternative of executor service and passing message from thread A to B in the most low latency efficient fashion using mechanical sympathy and all this stuff you might have heard. That was all about that. Then in Reactor 2, as we created the spec at the same time with the other companies, we wanted to be one of the first, nice implementer of this spec. Like, yeah, flag, it's us first. Unfortunately, we failed, but that's life, programming life. So we had existential question. I mean, the Reactor 2 project exists and it's used. It's even a transitive dependency on some project like Grails, but there are some side effects, there are some issues. It's not consistent with a much more successful reactive model, which is, in my opinion, RxJava 1. And, that created concerns around the framework, etc. And then, at the same time, Spring evolved, especially with Spring 4 and Netflix OSS and all Spring Boot. All the stuff we were trying to do was to focus on, this idea of microservice. After all, we Spring is free, but we still have to eat at some point, and we have to drive people to our nice platform, which is not free. And so our Spring project needs to be nice with this kind of architecture, but we didn't wait for them to ask us to do something about that because we had already ideas That's, you know, coming also, most of this stuff comes from the Netflix OSS as well, where we took some of these ideas as well and tried to generify and make something pragmatic around that. And you know, in the microservice world, there is also this aspect of concurrency, and that's where we asked, can Reactor do something? In that case, should we, in Spring 5, use a Reactor as a kind of hidden library and make something with publisher factory, for instance, to create under the hood a publisher that are used by Spring, etc. And we realized it wasn't that very efficient, because returning publisher, as we've seen in a few slides before, was really not providing a lot of semantics to user. So we just started the Reactor 3 project. Actually, it started as 2.5, but so much changes we had to change to the versioning as well. So we started Reactor 3 early December last year. And the interesting thing at the same time is we had the chance to also discuss a lot with the RxJava lead, David Karnock. And the guy is a machine, and he has a lot of good ideas. Unfortunately for him, he couldn't implement them already in the state of RxJava 2 by the time. Now they are here, fortunately for him. But he had so much idea and he needed to implement all this stuff as well. We created what we called a research project between RxJava and Reactor, which we called Reactive Stream Commons. And in that toy project, we started putting a lot of effort into creating real, after 6 tries, real working operation in a reactive stream world with side effect freeze. There are still some we need to debug, but it's already difficult enough to have this scope of operation like map filtering. Well, these ones are easy, to be honest, but merging like flat map, for instance, are very difficult to implement, and have a proper implementation for that in this research project allowed us to experiment and make this quite robust. Now this research project has derived into Reactor 3 and RxJava 2 type flowable, and even more. We are kind of happy with this collaboration. It's still going on, by the way. So that's a revival where we are. The collaboration effort. What Reactor 3 is actually now implementing most, if not all, of the reactive extension collection of operations, and it does that only in a reactive stream way. So that means everything we do in Reactor is purely reactive stream implementation, and we do that because Spring 5 in its story is using reactive stream as a basic. It doesn't use RxJava, for instance, as the core of this story. It does use reactive streams interfaces, and it does use for fulfilling this contract Reactor. And that's a difference, for instance, with, before someone asked me the question, what's the difference between RxJava and Reactor? One difference is, oh, that's a picture of David, actually. One difference is we have Flux, for instance, and they have observable, but observable is not implementing reactive streams. Publisher, which means if you want to use the nice operation in Spring 5 like save, which accept a publisher, so you can save multiple data coming from this publisher, and maybe return a publisher itself, you cannot pass an observable to this thing. You have to pass observable, in RxJava 2 at least, observable to .2 flowable, because you have to convert to the other type. We didn't want to have this noise because we have the chance to be requiring Java 8 as well, and they do require Java 6 because the main audience for RxJava is Android, basically. 70% of the user in RxJava world are coming from Android, so the need for Java 6 is important for them, but not for us, because mostly we don't have any presence on Android, for instance, with Spring, and mostly we focusing on microservices on the back end. So what's a Flux? That's the equivalent, as I just said, of an observable, for instance, but using implementation, using the reactive stream implementation. So for people knowing already RxJava, you won't be lost with this kind of signature. You have a kind of DSL starting with a generator, a static method on the Flux type, which is the reactive stream type, saying, okay, I'm going to generate this data, and there are various ways to generate this data. That's just the simplest way. Just, you know, it's just going to emit these 3 elements. And then you have all the same operation like flat map, or newly named operation, which actually RxJava 2 synchronized with. So we changed some name for some operation, but at least we are aligned with RxJava 2. And we have this kind of collection of operation. In that case, we're going to have the flat map, which might be a Spring data repository, which, if it implements a Flux as a signature method, automatically will pick up that it's a reactive repository, and that's the kind of support we're working on all across Spring portfolio. Everything in Spring 5 and beyond Spring 5, because some versions don't necessarily require Spring 5, will have the support for this kind of signature. So Spring Data, of course, is one main candidate, but you also have Spring Security as well, Spring MVC, and a lot more, Spring Cloud Stream as well. So you can kind of compose flows like that. In that case, we're going to just pass red, white, and blue. Flatmap just means explode this into a larger sequence and merge that back into the same flow. In this very case, we're just going to find a car that is matching, or all the car that is matching red, then white, then blue. So instead of 3 elements, after we're going to have a lot of elements. And all of that works in a back pressure way. That's the interesting thing. So we're not going to ask more data if the flat map is currently merging already a lot of data. We're not going to ask for the next one. We're not going to ask upstream for more data from just, for instance. All of this is handled transparently by Reactor. And then we have the mono, which is like Flux, but with all for much more less methods, because it only works for at most 1 data, maybe 0. It's a generic based type. So if you have a mono with a void, you know that basically it's typed to have 0 data flowing in. We don't need to have an extra separation. So the difference, for instance, with a completion stage or completable feature you will see in Java 8 is that the mono offers you, at least beyond the fact it's implementing reactive streams, it offers you the fact that you can defer the subscribe. When you do that in completable feature, for instance, when you do .then, the flow is already triggered, and it's a push based only. At some point, the then callback is going to be reacting. When you do that with a mono, you declare your chain of operation. It doesn't trigger the mono itself. It only triggers it when you subscribe to it, or block in that case, which subscribe and block for the result. And you shouldn't basically use block, by the way. It's there because it's useful for testing for very, very few use cases, but usually you don't block for this stuff. You would use subscribe, because subscribe will asynchronously subscribe to the parent operation, which is a chain of stuff. And in that case, it's quite, it's dealing with at most 1 data. So you can see that we start with a delay of 3 seconds. We transform this delay item, which is 0, in that case, the map D. We transform that in Spring 4, or we merge that with the potential or result, which is delay millisecond 2 seconds, and we transform that into Spring 5. So the fastest of these two is going to flow at some point and become, the result. If we use block, obviously, it will have waited for 3 seconds or 2 seconds, because 2 seconds is the fastest. So block is not really interesting. So to place that on perspective and comparing with all the stuff we have around in the JVM, especially RxJava, because that's our kind of pro. Java 8, for 0 to 1 result, there is completable feature. For 0 or n result, there is nothing. Stream is not reactive or asynchronous type. Stream is for local, in-memory, fast collection processing, or even generation of data. You can generate any kind of stuff with stream, but it's really push-based, so you don't use that for any stuff with latency behind, like a request to a remote service. For 1 result, there is completable feature, of course. For no result, there is completable feature of void. That's it. You can see with the reactive stream and Java 9 specification, you have publisher everywhere, except for maybe the publisher void, which is at least hinting you that it's a kind of 0 result, because nothing is going to flow. You can react to a void on next. Then there is RxJava 1. Well, it's not then, because it was predating all this stuff, actually. There is RxJava 1 with observable for 0 or 1 or 0 or n. And for exactly 1, there is single. It doesn't support 0 or 1. And for no results lately in RxJava, there is completable. And then we have Reactor 3, which only have these two types. So you can see the matrix here. We have for 0 or 1 result anyway, we are going to use mono. And for the rest, we use Flux, basically. And then there is RxJava 2, which has even more types, like maybe. So maybe 0 or 1. That's why actually I placed this explicit line, a 0 or 1 result, because otherwise no one has this concept. But 0 or 1, well, we have this concept. It's in fact, it's a 1 result exactly, which we don't have. Single and maybe and completable and observable are still here. But the difference in RxJava 2 is observable is completely backpressure free. It's like a bit the stream API in Java 8. We don't need that because we have Java 8 support, and that's a requirement for us. So they separated all the backpressure thing they did in RxJava 1 into an extra type, which is called flowable, and that's implementing reactive streams. So, you know, this stuff is actually in a simple jar like RxJava. You have the two types you're going to use from Reactor core jar 3.02 right now on Maven Central. And then, like in RxJava and Reactive Stream Commons, the project we actually source our stuff from, we have this concept of scheduling as well, which is a kind of super executor service we use with some kind of guarantees as well behind. So let's talk quickly about this execution service. This execution model. The execution model is actually quite flexible. Unlike, for instance, in Akka world, you will have an async boundary for a lot of things. Everything is a pretext to an synchronous boundary, so going to another thread explicitly. They changed that lately with the latest version of Akka Stream. They have what they call, and we call, fusion, which allows to avoid this massive overhead of switching thread for nothing. And in our case, and in the RxJava case, we don't really care about the threading because all the operations are basically thread safe. We use whatever the thread what used to emit these items. And if you want to explicitly change the thread you're running on, we have different operations. So by default, if you do subscribe in your main thread, the relationship is going to be simple. The subscriber is going to request on the main thread, and the publisher is going to emit items, the just items, into the same thread. If you use an operation we call publication, and RxJava call that observant, that's one of the very slight difference we have. If you use that, then the thread between a publisher and subscriber is going to be different for each item. They're going to use the same thread, but they're going to switch between the publisher and the subscriber. They're going to jump into another thread in that case. And we'll have a queue with the request mechanism to say, okay, this hasn't finished consumed this previous item, so I'm not going to request more data. So again, a story of back pressure. The thing is, because we have a cycle, you know, after n on next, we can request more data. It might contaminate the subscriber that would have a kind of actor, because you will segregate the stream upstream, and you will segregate the stream downstream with different thread. So, you know, we have a lot of resources about these two types. Dave Saya has written a lot of things. We don't have an official guide yet. The best one, to be honest, is the Reactive X site, and it's hard to do better than that. There is such a community effort around this. That's why we also adapt to what we think is an industrial standard for reactive programming, at least. But there are still a lot of resources available, and basically still, since Spring 5 is using Reactor 3 everywhere, at least it's important to get to know this difference, the difference of behavior, what is really reactive streams, etc. And this guy, Dave Saya, who's behind also Spring Boot and all the successful project, has really well explained in concrete terms, much better than me, actually. To finish with a quick tour of all the features, sometimes you might think that the just or merge or from iterable, from array are not enough, and you find this generator in RxJava or Reactor. So we came with something called create, which allows you to bridge simply a mono, for instance, one result at some point from a callback. If you had a Kafka call, for instance, often they use this callback mechanism, where you can pass an on success and on error. That's the kind of thing you can plug with the mono create basically. We use that a lot with our own Kafka support because we have a Reactor Kafka as well. So we can bridge asynchronous code if you have that. That's quite interesting. We also do that for Flux, but it's more dangerous because we have to explicitly say what you do in case of overflow. Really at the creation of the operation, you will have to say, okay, I'm going to keep the latest, I'm going to keep the everything at the risk of unbounded memory use. And that's the main difference with this kind of flow. We have also a debug mode, which is kind of unique in itself. So once you start using reactive libraries like RxJava or Reactor, you will realize quickly the step debugging is not as easy as usual, especially when you try to read the stack trace of your exceptions. Because yes, there is a lot of recursive call, and in fact, it's worse when you account for the cycle of the request. So with this stuff, at least, with Spring Boot in Spring Boot 2, we'll have a kind of UI to say, okay, enable that mode, disable that mode. But right now, you can use programmatically this stuff to say, okay, before I declare my operation, I want to enable this expensive debug mode. And when you do that, the exception, at least as a suppressed exception, because we don't change the type of the original exception, the exception you will see will have 2 more information in the end, the exact operation that failed, and the backtrace to the operation that failed. If you're familiar with RxJava or other composing libraries like that, it's kind of very, very useful, but because often you try to find where the error comes from, and with this thing you could just point, yes, that's this operation which failed. Otherwise, you're left to find it by yourself. And you know, the amongst all this other stuff, we have this. We have a few things like bridging the real world to the Flux, for instance, with the processor stuff. We use Companion to help you in imperative ways send data. If you don't have access to the Flux API, you can still use that from anywhere in the code. One of the interesting things we elaborated on with David actually was the concept of fusion. So what we tried to do at assembly time, which wasn't existing at the time in RxJava, is to make things smarter, makes the user pay less for whatever shit is going to try to write. For instance, if it's trying to write .merge with .merge with .merge with, we're smart enough to say, okay, we're going to merge all of that in one operation, and that's going to be merged with that, that, and that. Otherwise, you know, in the previous version of RxJava, for instance, you will have a Stack Overflow at some point because it keeps adding stuff in the stack. And we have the concept of microfusion, which is, in my opinion, even more interesting because, you know, all of this stuff, because of the reactive stream specifications and the asynchronous boundary, works with queues. But sometimes you don't want to create queues because queues are super costly. And if you do that on a very regular basis, you're going to have a lot of overhead in creating queues, for instance. And with microfusion, basically, we try to avoid creating queue. If the parent is something we can pull, like an iterable, like already a queue, we're going to avoid creating a new queue. We're going to use the parent as a queue, basically. And that's kind of very smart and very complicated to put in place. You don't want to do that by yourself. But we have that in place, so we merge, that's why we call that fusion. We merge the queue from upstream with downstream, so it doesn't need to create a new queue. And you know, when you start using just blah 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 flat map in every of your requests, you will be happy to have this overhead less because it's still a lot of overhead. And the last thing we created with the Flux concept is an extra type which we call parallel Flux to do fork join kind of mechanism. And you know, this stuff avoids you to write things like flat map basically. You can have a fork join mechanism where after the parallel number of your choice, you will have exactly the number of your choice rail or flux where you can do things. And then if you want to merge them back, you don't have to use a like flat map, you just use sequential. So that keeps things under the same level. On the functional level, it's quite nice because with flat map, you kind of see the nested, the callback hell, not that long enough after you start using flat map basically, because you have to open the callback, do inside the callback the merging of a new generator, for instance. So in that case, you can do just that on one single indentation level. It's not about that, obviously, it's not only about that. The cool thing about that is it's quite fast. It's actually faster than anything else. If you want to really starve your machine CPUs, basically we're here, and we're super happy because we're just super close to the bare metal implementation the JVM can do, and the JVM has access to very hidden doors to do some optimization. But in that case, we can really starve the CPU on your machines quite nicely. It's faster than using a Flux with flat map, for instance. It's faster than a lot of stuff. And yep, that was the JVM world. We experiment with the .NET world as well because it's cool. Actually, it's David who created this project. One thing missing in your rx.net is backpressure and reactive streams. So why not having a port of backpressure and reactive streams in .NET? And that's why David did. He created this Reactor core.net. It's interesting to see the relationship, between us, because he's still on a lead and a strong lead of Rx Java with a lot of ideas. But he created also a project for us. And it's on NPM, by the way, if you want to try, because we need also some feedback. It needs some feedbacks as well to keep on working on this stuff. We have also the same thing for TypeScript, because RxJS doesn't implement reactive streams, and we wanted to try the same concept over JavaScript or TypeScript. So we just he just ported that again. He's he has a kind of habit, or it's kind of fun for him. So he did that, and we are, because otherwise it doesn't exist, it would never happen. We are on npm.js, and you can use and try that. Obviously, it's very early stage, so we still need feedbacks for this stuff. And that's it. The ecosystem in terms of Spring is really interesting. We have Spring 5 plan, we have Spring Cloud, Spring Cloud Stream, Spring Integration, Spring Data, Spring Boot, Spring Cloud itself, Spring Security. For us, because that's a Spring part, but Reactor doesn't need Spring in itself, so we need to do some stuff by ourselves. Especially, we do the reactive driver part, they don't do. So, for instance, Spring will adapt to whatever container or driver you will use if you use Spring Data, etc. But ourselves, we have to transform a few technologies into reactive streams 3D technology, basically. That's what we do with Nedi. We have a TCP and HTTP client or server that just translate into Flux and Mono. That's all we do. We don't even create new types. It's not even a web framework. It's just using Nedi stuff and expose Nedi stuff. But from this stuff, you can create to an endpoint and return a Flux instead of doing that yourself. The same thing applies to Kafka. We have a reactive support for Kafka to send or receive messages into Flux instead of just receiving messages. And we are working on Redis, etc., because Redis is also supported by Pivotal. Maybe at some point we will have a RabbitMQ driver. And we work on extra add-ons, like we'd like to have we really like to have a kind of console. We're still a lot working around that, but a kind of console that works for all Spring 5 projects. So you will see in the same console a kind of diagram of your application architecture with multiple applications. Something I really want to actually correlate to the work done by Ordina around the microservice dashboard, but something that looks alike with the reactive comprehension, basically, because each operation some of the operation you have in a flow might have back pressure, so you might have item sitting in a queue, and you might want to know about this item sitting in a queue, because if you lose the application, you lose this item sitting in a queue, maybe. So all of that, and that's actually quite nice to conclude on. All of that is a nice reminder to say everything reactive, maybe not, because blocking is still faster. Anyone saying the opposite is lying to you, like what they did with the Brexit. And if you, before I had actually Brexit and then everything reactive on the same slide, it feels the same way. But if if you have some cases like IoT or mobile to REST endpoint connections, or cloud-ready application where you share a lot of your resources and you don't want to spend 10,000 threads from the Tomcat container for one application, but at most maybe 4 like Native or Node.js, or Node.js is even only 1. So, and they can do as well, you know, you don't need to have 1,000 threads. If you have this kind of concurrency use case, yes, that's cool. But if you have like one long living stream of things that will never be concurrent with anything else, of course it would be faster to use the blocking mechanism because it's just direct. It doesn't need a queue in the middle. It doesn't need a request lifecycle. Yes, it's just the way it works. And if the system were more efficient, or the JDK maybe was more efficient in organizing threading, maybe it would be even nicer in this way. And yeah, so maybe not everything can be reactive, and that's what's cool about Spring Framework 5. Spring Framework 5, basically you take your Spring 4 application, you upgrade to Spring 5, it still works. So that, you know, as usual, it's backward compatibility. But in addition of that, as an opt-in, if you have use cases for that, like IoT again, like concurrency or mutualizing resources, then you can start using the whole different branches, which doesn't depend on servlet, because obviously historically the Spring depended on servlet API as well. But on the other tree of dependency, actually we don't need servlet, because under the hood we don't even adapt necessarily to servlet. We can support servlet 3.1, so that's cool for Tomcat 9, for instance. And Tomcat 9. But we also have direct support for Netty, for instance, which is cool via the Reactor Netty stuff, but also we support RX Netty directly. And we support things like Undertow, so it's very decoupled now from the servlet API. And basically it's cool because in the end, you know, the programming model is not that different from the annotation perspective. You still have annotation like get mapping, for instance, but instead of returning an account or maybe something else that a listenable feature of account, you will just return a mono account, and behind we know that it's going to be a reactive endpoint. So like kind of cool, we have all this stuff. So in that case, that just means the repository will eventually respond an account, because it takes time to go to the repository and get the account and reply that to the client. And that's cool. In that case, that's more interesting because maybe the account comes from the client. And if it's a 3G connection, for instance, it might take time actually to read all the payload, all the packets to get the account formed. So in that case, we have mono, which is only going to be triggered if you use it when the packets are completed. And if you use Flux, it will use maybe, if you use Flux, you will have actually all the packets flowing. But if you use mono, it will aggregate for you in a non-blocking way. That's also an interesting thing about semantics and cardinality. When you have a difference between Flux and mono, for instance, you can, even from a type perspective and a post-processing perspective in Spring, we can decide if you wanted to aggregate things or just flow things. So a stream of 1 or stream of n. So we do the same here. We also support serialization in a non-blocking way if we can. Otherwise, most of the driver we have today use most of the serialization mechanisms we have today are blocking. They are not even driven, except if you talk about Alto XML, for instance, or this kind of thing. Jackson, for instance, is blocking. It's not even driven. So we had to write a bit of stuff ourselves to actually read in an event-driven way payload from a JSON array, for instance. We don't use Jackson in that case. We don't need to aggregate everything, wait for everything. We just pass the comma and the semicolon to just say, okay, that's a packet. And for individual packet, we will use Jackson, for instance. So we do these kind of things. Also, we have a mono void as a return, so we don't return anything, but we want to signal when to close a response. In the case of HTTP, you want to close a response at some point, maybe, or say that you don't have anything to send at least. So we can return mono void whenever the save has successed, for instance, has succeeded. And if it doesn't succeed, it's going to send an on error, one of the callback implemented by mono and reactive and exposed by reactive streams. And if it didn't succeed in that case, it will trigger, as before, a kind of exception handler you can implement yourself as well. So the MVC model can still work, basically. What changes is the way you organize your logic inside your conventional application with its annotation. Instead of doing blocking stuff, you will have a lot of chaining stuff like .map, .filter, etc. That's the way it changed the perspective, because you add continuation on whatever happens instead of doing things immediately. And we support, obviously, because again, RxJava is our bro, so we support completable, but we support a lot of RxJava as well, directly even in Reactor. So if you use RxJava in your Spring application, you're still fine. It's cool. We're not going to hate you, even if internally we use Reactor and you will have two dependencies in your class path like Reactor and RxJava. It's still fine. It's a bit like the time when you had Dojo and jQuery maybe in your class path. And if you have even streaming stuff, or if you do like microservice call to another microservice, you will use a client. So usually with the current version of Spring, you will use async or normal REST template. But in Spring 5, to avoid breaking the compatibility with REST template, we have introduced something new called the web client. And the web client is basically the reactive version of the REST template. You can communicate to a remote service. It will transform this into a Flux or Mono, depending on what you want. It may be a stream of alerts using SSC. It may be just one result, like give me maybe this user from this service. It's the kind of thing the web client supports. So you see the semantics doesn't, here the semantic change a bit compared to REST template, but the whole thing of calling something else, like being a proxy, can be implemented like that, basically. You don't have anything else. It can be a Spring Boot application with just this method, connecting to alerts from another microservice. And the good thing is, even if I talked a lot about that at the beginning, you don't see at all the reactive stream specification. In fact, it's just done for you, which is great, because that's really error prone if you do that yourself. So that's it. We do that. We have other efforts, Spring Boot with a reactive starter, Spring security, which is kind of important because of the context issue. When you have a flexibility in the execution model and a project is using a lot of thread local, for instance, it's a kind of difficulty to pour that into a reactive model. But fortunately, Rob was really interested. Rob Winch, the lead of Spring security, had already ideas about that, and we have ways to solve this as well, to secure some flow. Spring Data, of course, if you want to access MongoDB or Postgres, because they have already a synchronous driver, or Couchbase. Spring Cloud, of course. Spring integration. Instead of having channel, you can react on flux of messages, etc., etc. So that's basically it about quick introduction, quick tour about Reactor. There is a lot of things to be said, and actually we did a similar presentation in Spring 1, but that was split into 4 or 5 different presentations, and I tried to aggregate all of them. But to give you an overview of what we're doing right now in Spring, we are right now, Spring Framework 5 is right now M2, so you can even download the latest as a fixed version, not the fixed release, but a fixed version. It's very interesting where we're going, because in Spring Framework 5, for instance, we have the functional support as well. So that means you don't even have to declare your MVC handling as annotation. You can use something, a construct very similar to maybe Vertex and especially Ratpack, I would say. Construct very similar, where you just add action and basically compose your routing and have an independent routing independent of your application. So there are new features, not only reactive but also functional, and but also, and I think that's quite important, we don't forget about the current existing user base. And we try, and that's going to be our critical mission, we try to have a learning curve which is not all or nothing for our users. And usually, a reactive person will come to you and say, well, you're not using reactive, your design is shit, etc. But there is a trade-off, again, there is a trade-off in using these techniques, and I think if we educate enough people about when to use this and when to not use this, and I'm fine with not everything using it, that would be great, I think, for everyone, because people will be will not be fooled anymore by this kind of speech anyway. That's basically it. If you, I didn't have any question about my French accent, and I talked a lot faster than usual. So that's interesting. So you're all sleeping already or waiting for the barbecue. I don't even know the time actually. Oh yes, it's very time to do barbecue. So any question about or roadmap or why we do that, or usually I'm being asked why we do that if there is Rx Java. But if no one asks this one, I'm not going to answer this one. Why there is that and not Rx Java? Any question? Yeah?
How do you get the benefits from HTTP2, for example?
So the question is, how do we support HTTP2 or get any benefit with HTTP2? It's a work in progress right now for Spring Framework 5 milestone 3 maybe, hopefully, maybe will be M4. We don't have an immediate support. Besides the fact that React on 80 can support it, Spring doesn't expose it yet, because there is a lot of concept new to HTTP2 we want to correctly represent, especially the streaming. The step streaming over the same HTTP connection is important. We're working on that. This is a TLDR. But it will be here for Spring 5. Any other question? I can answer actually. Yep. Yes. So the question is, we not. Can I repeat that question actually? No. The question is, do we have any more documentation about React on 80 in a British way? Nope. But what we try to do with React on 80, as I said, is really to not create a web framework or even a standalone any kind of web stuff, basically. We want to be used as a driver, not as a web framework. So that translates into, it's really exposing Nedi concept. It doesn't invent any new type. For instance, you will find HTTP headers from Nedi directly. You will find even the channel handler that comes from Nedi directly. We don't try to invent things on top of that. So one thing is to know a bit of Nedi, of course. And the other thing is to know about Reactor core itself. And once you know these two things, basically you are halfway into knowing React on 80, because it would just translate Neti into Flux or Mono. The plan is to develop more guidance. Probably we try to focus more on a Spring level perspective, like how you will do that first from a Spring perspective if you use Spring, the client or the server. Fortunately, we might do that for the next weeks, because we have a new person joining the team, the Reactor team, and that is going to be his first task. Do some documentation, man. Awesome. I'm glad I joined Pivotal. No, it's hard right now because I have a kind of a focus split between a lot of things, but and Spring is going to address that first. But as soon as we can, we're going to address that for React on 80. Obviously, right now, what we do is working directly on the community channel. We are on Gitter, and you can access that through the GitHub. There is a link. And a lot of people just interact directly. And that's actually, it's very difficult because, you know, instead of solving the issue and having a proper documentation, I'm overflowing myself by trying to respond directly to each person. At some point, I'm lagging behind, and some person is just saying, "Hey, what are you doing? I'm going to whip you." But I kind of like you guys, so you can just ask me directly on Gitter anyway if you have questions. Any other questions? Yeah, Andres. So there is, it's far away. Oh, did I skip it actually? Yeah, there is that. There is, if you go on Spring.io blog, there is really the way he explained stuff. So the question was, do we have any kind of resources for newcomers to reactive programming? There is this series of links. Actually, I did a release announce for 3.02 like last week, and at the end of still on the Spring IO blog, so you can still see that on the same blog. You will see at the end a list of resources you can use. Oracle has actually a nice documentation in progress. If you look for Oracle on Google, Oracle Reactive Streams, you will find the community page for Reactive Stream explaining from the Oracle perspective, which is kind of amazing, the Reactive Stream concept. Another bad way, I mean, in Java 1, they did a few presentations which were interesting. I wasn't a fan of the JDBC reactive driver because it didn't seem really reactive, but the general reactive streams presentation was really nice. Plus, they use Reactor in the presentation, which is kind of an achievement. Yes, thank you, Oracle. But you know, they have some comprehension, and the page is very interesting. But I don't have the link. You just need to Google reactive streams Oracle. That's the official standard way. You can pass that to your offshore department as well, so they see, oh shit, it's on Oracle. I can use that. That's it. Any other question? Nope. Oh, I'm disappointed. No one asked this Java versus Reactor one. I did too much warning over this one. But yeah, if you had this question anyway, I'm going to answer it. If you had this question, refer back to this slide, basically, which I should upload if they are not already on SlideShare. But if you have a question about Java versus Reactor, especially Java 2, you just compare the two last column, basically. And then you assess for yourself, am I Java 6? Do I need all the cardinality they expose? Am I going to use a Spring 5 application? That's kind of easy to answer by yourself. Fortunately, if you use them, and you find bug with them, it's going actually to fix all bugs. And if you use us and find bugs as well, we're going to also fix bugs in Java 2. It's kind of a very close collaboration. So yeah, it depends. On Android, you will be forced to use Java 2 though, because right now we need Java 8. Right, I self-answered this question, so I guess there is no more question, and it's time to drink more. To drink. Did I drink before? Thank you.